Okay, welcome to 3.3 polynomials and synthetic division. Today we're going to be dividing polynomials using long division and synthetic division, and then we are going to show how that will find our x-intercepts for our polynomials. So here we go. Let's first take a look at just a simple problem here of dividing 310 by 6, and let's set it up using long division. Okay, so I'm going to set this up just like back in elementary school, right, where we had 6 goes into 310 how many times? Okay, so we know 6 does not go into 3, so we move on. 6 goes into 31. Well, we say 6 can go into 31 5 times, so I'm going to put that above the 1. And then I multiply. I go 5 times 6. That will give me a 30. I subtract that. 31 minus 30 is a 1. I bring down the 0. 6 goes into 10 one time. 1 times 6 is a 6. Subtract that. And we get 10 minus 6 is a 4. This is our remainder. Right? That's our remainder. This up top here is your quotient. That's our quotient here. Okay? Then we have our dividend and our divisor. So this in here is our dividend. And this outside is the divisor. So if we were going to write this out, most of us should be able to tell that, okay, 310 over 6, which I had my dividend over my divisor, right, was going to be equal to 51, and our remainder was 4 over the divisor 6, which can reduce obviously to 51 2/3. And we know that actually this can be written as 51 plus 2/3. That's the same thing. Okay? So when we're writing out our long division problems, we need to be able to write it in as a fraction or in fractional form. Okay? So we did just that. Look what we wrote down. This 51 here was your quotient. The 4 was your remainder, and the 6 was your divisor. So when we write this out, we have our dividend divided by our divisor, the dividend divided by our divisor, so equal to our quotient plus the remainder over our divisor. That's what we just said. And if we actually multiply everything here by the divisor, right? Here, here, and here. Well, the divisor will be left with this guy, and all the other ones will cancel out. So then we're left with the following. The dividend will be equal to the divisor times the quotient plus the remainder. And that's how we're going to be writing these as a fraction. So let's give one a try here. Okay, we're going to divide the following. So when we're dividing these, we set it up the same way as when we just had numbers. Okay, so we're going to start by taking the first term, 6x cubed, and dividing it by the first term on the outside. Okay, the first term in the dividend divided by the first term in the divisor. We get 6x squared. I'm going to put that to start our quotient. Our next step is to multiply your 6x squared times x minus 2. We multiply this in here. We get a 6x cubed minus 12x squared. I'm going to put this underneath here. I'm also going to put this in parentheses to show that I need to subtract everything here, everything in this binomial. So these first two terms, this should always cancel out if you divided it correctly. Then we have a negative 19x squared minus a negative 12x squared will give us a negative 7x squared. And then I continue. I'm going to repeat this process. I bring down the 16x and then I repeat it. I have negative 7x squared divided by x. That will give me a negative 7x. I put that up top to continue my quotient. Then I multiply my negative 7x times x minus 2. Multiply that guy in. There it is. We get a negative 7x squared plus 14x, right? I put that underneath here and subtract. Negative 7x squared plus 14x. I put that in parentheses and I subtract. These will cancel. 16x minus 14x will give me 2x that's left. I bring down my minus 4 and I repeat it one last time. So I take the first term here, 2x. I divide that by the first term here, x. I get a 2. I put that up top as my quotient. I multiply out 2 times x minus 2. I get a 2x minus 4. I put that underneath here. And I get a remainder of 0. When you get a remainder of 0, that means that both of these are factors of the dividend. So I could actually write this out as both of these are going to be working. If I have my 6x cubed minus 19x squared plus 16x minus 4, this I now know is factored to be x minus 2, right here, times what we got as our quotient, 6x squared minus 7x plus 2. If you did have a remainder, then you would write that out. I would have my quotient plus my remainder over the divisor. The quotient we got was 6x squared minus 7x plus 2. Then I'd have my remainder, which is a 0 here, over the divisor, which is x minus 2. That's how you'd write that out. This is obviously going to be 0, so plus nothing. Okay? Alright, so you guys give this one a try. Set it up the same way. You're going to divide it and then write it in fractional form, which is as your quotient plus your remainder over the divisor. Okay, so hopefully you gave that a try. Let's see if we got the correct answer. We start by dividing x squared divided by x, and we get an x. We start by putting that up top. Then we multiply x times x plus 1. We get x squared plus x. We put parentheses and we subtract this whole thing. X squared plus x. Put parentheses, the first ones will cancel out, those first terms. Then we subtract 3x minus x. We get a 2x here. We bring down our next term and we repeat it. We have 2x over x is a 2, so we put a 2 up top. We multiply here and we get 2 times x plus 1 will give us a 2x plus 2. We put that in parentheses and we subtract it. 2x plus 2. We subtract it. 5 minus 2 is a 3. So therefore, your answer following this form here, our quotient is x plus 2. Then we have plus, our remainder is a 3 over your divisor, which is an x plus 1. That's your answer written as a fraction or fractional form. So when you divide these two, this is what it will be equal to. You also can write this as, coming down here, you can also write this as, we know that when you have a mixed number, you take these two and add it to your remainder. So this is the same as writing x plus 2 times x plus 1, and then we have plus your 3. So that was going to be your quotient times the divisor plus the remainder. This is the other way you can do it. You can also check your answer by multiplying this out. If we multiply all of this out and combine like terms, we should get back to this quadratic here. So if we do that, let's see what happens. We go first, outer is an x, inner is a 2x, and last is a 2. Bring down this 3 over here. That's an x squared plus 3x. And then we have 2 plus 3 is a 5, which got us back to our original quadratic. Look at that. There we go. So this is another way to write it. Okay, moving on. Another long division problem. I wanted to do this one with you guys because notice there are some terms that are missing. So when that happens, the easiest way is to just put some placeholders in. We have a 0x squared, a 0x, and then a minus 1. And then you do it the same exact way. So we have x cubed over x is going to be x squared. Okay, we multiply that out. X squared times x minus 1 will be x cubed minus x squared. X cubed minus x squared. We put that in parentheses and subtract the whole thing. This is why we put in the placeholder, because it's now a little bit easier to see that we have to do 0x squared minus a negative x squared will give me a positive x squared. I'm going to bring down that 0x here as my placeholder, and I'm going to do it again. X squared over x will give me x. Put the x up here. We have x times x minus 1. That will give me an x squared minus x. I'm going to put that in parentheses again so I know to subtract the whole thing. X squared minus x. Okay, these will cancel. 0x minus a negative x will give me a positive x. I bring down that minus 1 and I repeat it one last time. X over x will be a 1. This is a plus 1. 1 times this whole thing. 1 times x minus 1, our divisor, is x minus 1. We subtract that, put it in parentheses and subtract it, and we get a remainder of 0. That is telling us that both of these are factors. So both x minus 1 and x squared plus x plus 1, those are both factors of your cubic polynomial. So we can actually go ahead and write this in factored form, which will give us, if I write my x cubed minus 1, this is factored to be x minus 1 times x squared plus x plus 1, which actually, if you remembered the difference of cubes, you would have gotten this as well. Okay? All right, moving on here. We're going to do another long division, but now instead of a binomial, we have a trinomial here. We do it the same way though. Okay, so again, we will start it out by doing 2x to the 4th over x squared. We get a 2x squared. Put that up top, 2x squared. We multiply this in, 2x squared times x squared plus 2x minus 3. I distribute that in, and I get a 2x to the 4th plus 4x cubed minus 6x squared. Okay, so you have to make sure that you multiply it to the entire divisor. Put this in parentheses, and I'm going to subtract this whole thing out. So I have 2x to the 4th plus 4x cubed minus 6x squared. Close your parentheses, and we subtract. These will cancel. These will also cancel. We have a negative 5x squared minus a negative 6x squared is the same as negative 5x squared plus 6x squared. That will leave me with x squared, a 1x squared. I'm going to bring down all three of these, or both the 3x and the negative 2, because we're dividing it by a trinomial. So, I repeat it one more time. X squared, the first term, divided by the first term, I get a 1. So I put a 1 here. I multiply 1 times x squared plus 2x minus 3. I get x squared plus 2x minus 3. And then I put this in parentheses and I subtract the whole thing. These first two terms will cancel. 3x minus 2x, that will give me an x. Negative 2 plus 3 will give me a positive 1. So writing this out here, I get my quotient. My quotient is a 2x squared plus 1 plus my remainder over the divisor, x squared plus 2x minus 3. You can also write this as multiplying these two out and adding the remainder. So the other way to write this is you can look at what you would do for a normal mixed number. You'd multiply this denominator times this one here. So I'd have a 2x squared plus 1 times x squared plus 2x minus 3. And then I would add on my remainder, plus x plus 1. Okay, both of these are correct. This last one, you can actually multiply it out, add it to this, and you should come out with this quartic. Moving on, here's synthetic division. So synthetic division, you guys can write down the steps for it if you'd like. Most of us should remember synthetic division from last year, but if not, we are going to go over it right now. Here we go. Okay, we're going to use synthetic division to divide. The thing with synthetic division is it always has to be x plus a number or x minus a number. This has to be linear. It has to be linear in order for you to divide using synthetic division. So the previous one, we could not have used synthetic division. Okay, so in the steps, you should have seen to reverse the sign of the divisor. So that's this one right here, x plus 3. And the reason why we're reversing the sign is because if this divides out perfectly, meaning we get a remainder of 0, then negative 3 will be your x-intercept. So let's see what happens. You're going to list all of the coefficients, and if there's one that's missing, a term that's missing, you need to put in a 0. So I'm going to write this out as 0x cubed so that we don't forget to put in the 0 there. Okay, so now that I put the 0x cubed in, now I'll list all of the coefficients. I have a 1, 0, negative 10, negative 2, and 4. Okay, the next step was to bring down the first coefficient, and then we multiply. Negative 3 times 1 is negative 3. Then you're going to add these. You get negative 3. Then you repeat it. Negative 3 times negative 3 is a 9. We add these, we get a negative 1. Keep repeating until the end. Multiply, we get a 3. Add 3 minus 2, we get a 1. Multiply, we get a negative 3. Add, and we get a positive 1. So what this did was, this last number is always your remainder. This one here is always your constant term. This one will always be your linear term. The next one is your linear term. The quadratic term and the cubic term, if it has one. So we could put these in. This is x cubed, x squared for quadratic, x for linear, and our constant. So therefore, to write this out correctly, we'd write our what we got as our answer, our quotient, as x cubed minus 3x squared minus x plus 1 with a remainder of 1 over our divisor, and our divisor was an x plus 3. Okay, that is how we would write our answer using synthetic division. And we do that because we write as our quotient plus our remainder over the divisor. Okay, the remainder and the factor theorems, those are going to be, we kind of talked about them already. The remainder theorem, once you divide, then the remainder is going to be the last term. And whatever you plug in here, your k, then that will be your remainder, which will also be giving you a point. So therefore, you'll have the point kr, whatever the remainder is. The factor theorem is saying if you get 0, so a polynomial f of x is a factor, if the remainder is 0. That's what the factor theorem is telling you. Okay, so we're going to use the remainder theorem to solve this. We make sure no terms are missing. They're not. So we solve. We're going to use -2 here in the little box. We write our coefficients in. Okay, we solve it the same way. We bring down the 3, we multiply, we add, we multiply, we get -4, add, 5 minus 4 is a 1, multiply, -2 times 1 is a -2, and then we add, we get a -9. So therefore, f of -2, what we just used, is equal to the remainder, the last number, -9. Which is telling us a point on this cubic. Okay, this is a point on your cubic. To check this, you can check by plugging in. And you'll get the same answer here. Okay, so if we plug in f of -2, my x to be -2, we should get the same thing, -9, to make sure we got it correct. 3 times -2 cubed, 8 times -2 squared, 5 times -2 minus 7. Okay, let's see what we get here. We have 3 times -8. We have plus 8 times 4, a minus 10, a minus 7. This is a -24 plus 32, minus 10 minus 7. Okay. 32 minus 24 is a 8, minus 10 minus 7. -2 minus 7 is a -9. So we just proved that we got the same answer by plugging in or using synthetic division, which is a lot simpler and faster. Okay? And, all right, let's see what else we got. This is when we have repeated zeros. So what we're going to do here to show that both of these are factors. So when they're factors, we want to get a remainder of 0. So we'll start this off by using the value of 2 in the little box. And we'll list all of our coefficients: 2, 7, -4, -27, and -18. And we're going to do the same thing. So here we go. We start out by bringing down the 2, multiply, add, multiply, add, that's a 18, multiply, that's a 36, add, 36 minus 27 is a 9, multiply, 2 times 9 is a 18, add, and we get a remainder of 0. That's a 9, sorry. That is telling us when we get a remainder of 0, it means that x minus 2 is a factor. Okay, so the next thing you're going to do here is now we're going to test this one here. So in order to test that, we're going to use -3, and we're going to use these values here. This was your remainder. This is your constant. linear, quadratic, and cubic terms. Okay, so now we're going to test the x plus 3 with this cubic, meaning we're going to take all of these coefficients, the 2, 11, 18, and 9, and we're going to use those to see if negative 3 is also a factor. So here we go. We bring down the 2, we multiply, we get negative 6, add, 11 minus 6 is a 5, multiply, add, multiply, and add. And therefore, we get a remainder of 0. And when the remainder is 0, it means it is a, whoops, that's a remainder. Remainder is a factor. So that means that x plus 3 is also a factor. Then this is our constant, linear, quadratic terms. So here's what we have so far. We know that we have x minus 2 and x plus 3, x minus 2 and x plus 3 are factors. Then we have this quadratic that's left over. We have 2x squared plus 5x plus 3 is what's left over. Then we can finally factor this last part. So I'm going to factor this by doing a times c, 2 times 3 is 6, and we say what multiplies to 6 and adds up to 5, 2 and 3. Okay, so I'm going to take this 2x squared plus 5x plus 3, and I'm going to factor it by replacing my 5x with 2x plus 3x and factoring it. And say, what can I take out from the first two terms? This is factoring by grouping. I take out a 2x, I'm left with an x plus 1. Here I have to have the same thing left over, an x plus 1, so therefore I'm going to take out a plus 3. When I look here, I see that I have both x plus 1 in common, and then I'm left with a 2x plus 3 here. That is factored for that quadratic, and then just bring down both of these. Bring those down. We get x minus 2 times x plus 3, and then we had this quadratic that was factored, x plus 1 times 2x plus 3. Those are going to be all of your factors for that quartic polynomial. We just showed all of them. So now you can actually find all of the zeros. Okay, so we already know the first two because we just proved it. We have x is 2. X is negative 3. That's a negative, negative 3. This one will give me negative 1. And this one will give me a negative 3 halves, which is the same as negative 1 and a half. That is going to be all of your x-intercepts, all of your zeros, all of your roots. Okay? So finally, here's what we know using the remainder in synthetic division. If the remainder r is equal to 0, if the remainder is equal to 0, then it is a factor. If the remainder is equal to 0, then you have k, comma 0 is an x-intercept. All right, that wraps up 3.3. Thanks for listening. I hope you learned something. See you tomorrow.